All right. As you can see, I have not finished writing out the lesson on Terraform Docker today, but we're going to go ahead and run through what that looks like. This is pretty handy for if you want to be able to run Terraform without actually setting up Terraform. So let's say maybe on an EC2 or on another machine, like maybe you just set up a new machine or you're on somebody else's machine, whatever the use case is. You could just have your Docker file containing these Terraform instructions in a repository that you just fork down wherever you need to run it. Let's take a look at what that Docker file looks like. It's, as you can see, extremely simple. It's essentially just letting us know that we want to pull the latest Terraform image from HashiCorp. We're going to be creating a work directory called Terraform, and we copy everything in the current working directory to that location. Terraform is our entry point because that's the command that we're going to use to do all of this. So let me see if, if my history grep will even show this. There is, okay, so that's a Docker file. And basically, once you have a Docker file, you're going to want to do a Docker build. I already have it. I'm actually running it right now, or at least I thought I was running it earlier. But if I look at my images, image list, we can see that I have a Terraform Docker image. So I can run it if I can just remember the command. It's something like Docker. We're going to run the Docker command with a few parameters. This -v basically says that we want to create a volume. We want to mount something, right, to something else. So let's say if I want to mount everything in my current working directory, I can do something like pwd equals, or not equals, sorry, colon Terraform. And I'm also going to do a -rm so that this container gets removed as soon as I'm done using it. And what else? We also want to be able to include the PEM key that we need to SSH into an AWS EC2 instance. And we also want to, what was it? I feel like I'm missing something. If only I had access to this terminal that's just been frozen all this time. Let me try to exit out of this, actually. Nope. Yeah, that might take a while. Let's see. Okay, there we go. It's finally finished whatever it was doing, I guess. But this is the command that I was using earlier. We're using a Docker run. We're passing --rm to remove the container. Once we're done doing what we need to do, we do a -v to set up a volume. In this case, we want everything in our present working directory to be moved over to, or mounted, I should say, inside the Docker container within a Terraform folder. We use another -v to specify that the configuration we have in our user hidden AWS folder will be mounted at this root location with another hidden AWS folder in the container. We then use -w with the /Terraform because that's our entry point, and we specify the image that we want to use, which is the latest version of Terraform from the official HashiCorp repository. We then run the command we want to run, which is apply. And as I was showing on Saturday, we could use auto approve when running apply to bypass any prompt for a user, because we won't actually be able to input that prompt in a Dockerized instance of Terraform. So let's see what this looks like. Actually, before I run this, I'm going to run a Terraform plan. Should already have run in it earlier, so I shouldn't need to do that again. And we get our plan results. If we take a look at what all this is, it should match what we have inside of the Terraform file we have in this directory. So basically, let's look at main.tf. What we're doing is we're creating an AWS EC2 instance called main node. We are specifying that we want to be on US East 1. We are specifying we want to use version 4.16 of AWS as a provider for Terraform. And we are also creating some other resources here, VPC, a subnet, a security group, and we're also outputting some variables that we are going to need in order to be able to run an Ansible playbook. Chad, you're here now, right?
Yes.
Do you remember from the last cohort when I ran this?
Sort of, kind of. I wouldn't say not real well.
Okay. I think I demoed it once. I'm gonna have to like go through and make a few changes. I haven't run through the actual Ansible playbook yet. I kind of misplaced those files, but that's essentially the end goal for this, which I'm going to work on after the demo. But the idea is you're able to kick off an Ansible playbook from Terraform. So this is a powerful combination of automation tools that allows you to run an Ansible playbook, which can allow you to set up a new instance. So in addition to being able to set up an EC2 instance, we could also use an Ansible playbook to set up whatever resources we need on that instance in order for us to run an application or set up a web server, whatever we need it to do, right? So that's the power of combining Terraform with Ansible playbook. Ansible itself is, well, before I jump into Ansible, let's just go through and finish the rest of what this looks like. Because this is about Dockerizing Terraform. As you can see, if I run my Docker PS, we won't have container because it's already spun itself down, because the command I gave has the --rm argument for remove, but it's still able to execute all these things. So did I run the plan yet? I did not, right? I just ran the plan, not the apply. Now I'm going to run the apply. And before I run the apply, let's take a look at AWS to see if anything is running. Nothing is running, which is good. So let's go back to here. Let's do an apply auto approve. And instead of running from my Terraform instance on my local machine, it's going to be running from a Dockerized container. So before it finishes, if I do a Docker PS, you can see that I have a Docker container running Terraform. So this is also handy if you're running into any kind of issues setting up Terraform locally and getting that to run. Because you're running it out of a Docker container, you could be very explicit about what image you want to use in order to run this. In my case, I think I showed you, we are using an image that's provided by HashiCorp, the creators of Terraform. So let's take a look at AWS. We see that our main node has been created. And if we were to look at our VPCs and the other resources that we have in our main.tf, we should see that they are created as well. What did I name my VPC? My demo VPC. So I guess we're still waiting on that. Or did I not tag? I didn't tag it. So that should be this. That matches. And once I'm done with all of this, just like running my Terraform apply, I can just run a Terraform destroy to spin everything down. So I will provide this Docker file and some instructions on how to set this up in today's README. And we'll also talk about Ansible, which is a configuration management. It's, well, not necessarily configuration management tool, but it can be used as one. I think a better way of describing Ansible is to describe it as an automation tool. It's able to, yes, apply configurations, but also run commands in a standardized format by utilizing something called playbooks. Playbooks are essentially a way to a script, in a sense, a way to specify a series of commands and instructions that you want run. So let's take a look at what this might look like. An example playbook will be very easy to read. It's designed to be human legible. We see here, for example, we've got two playbooks, two books essentially, two plays. One for configuring web servers and one for configuring database servers. And we see that we have tasks that are also pretty easy to understand. We're going to be installing Nginx. We're going to be starting the Nginx service. For the databases, we are going to be installing MySQL and then starting those services. And that is the power of Ansible. The other component to Ansible would be the inventories. So in addition to being able to specify the commands that you want to run, you can also specify the resources that you want to manage. And these resources are called managed nodes because essentially Ansible works conceptually off of nodes, right? One of the benefits of Ansible is that it is able to execute these modules on machines and systems that don't have Ansible installed. So you don't actually have to install Ansible on the machines that you're running these commands on because Ansible runs from what is called a control node. And the control node is where you install Ansible. So in our case, when you run your brew install or sudo apt-get install Ansible on your local machine is the control node. The hosts that you add into your inventory, those are your managed nodes, the nodes that you want to be able to run Ansible playbooks on. Any questions on that? Cool. Reno's going to be going over Ansible inventories tomorrow. Preston will cover playbooks on Thursday. And I think there's going to be an exercise that Chandra will have ready for you on Saturday. So let's backtrack a bit and let's talk about from last Saturday. Where was it? The data sources. I don't know if that's on my local machine. I think it's actually only up on the repository. Okay, so I added this new section, which covers everything that we did on Saturday. So what we did was we created, in order to demonstrate the remote backend, we created a backend. The idea being that if you were to have your own project at an existing organization, they'll probably have these backend resources already created for you, right? Or at least an infrastructure for databases and or whatever other resources that you need. And in our case, for what we're trying to do, we need an RDS server or a resource so that we could create a lock file for our Terraform states, which we're going to be storing on S3 buckets. I said RDS, I meant DynamoDB. And from there, we are going to be able to use modules to create multiple instances, multiple EC2 instances to simulate different environments. We're going to have one for dev, for staging, and for prod. And all of these will have their own dedicated Terraform state inside of our S3 bucket. Finally, they will be using data blocks inside of the Terraform configuration in order to reference the pre-existing Terraform state block, DynamoDB resource. So let me see if I can find where all of that was. Might still have it open. I should still have it open. Okay, cool. There it is. This is actually a good exercise to run through. If you haven't run through this yet, which you probably haven't because I didn't push this until after class on Saturday, run through it. We're gonna be doing yeah, you'll be doing exactly what I did on Saturday, and I'll run through it one more time just so you could see. But I wrote this in a way that you're not just copy pasting the code into Terraform, but you have the ability to write it out all on your own. So first, you're going to be making a project. In this case, we're using something called myTF project. And then you're going to create multiple files, main.tf, and then a main.tf. Well, let me backtrack. A main.tf at your root project directory, and then a main.tf in your subdirectories, one for dev, one for staging, one for prod, and then one inside of modules subdirectory, because these main TFs are simply going to be referencing this module. They're not going to be resource blocks. They're going to be module blocks. Inside the main.tf at your root level will be the data block that references the backend that we're going to be running from a different directory. You shouldn't have to do this step if you're referencing the exact same resource that already exists. So let me jump into this directory. Yep, backend, and let me run this. I shouldn't need to init because I've already init last Saturday. If I do an apply auto approve, it should spin up fine. All right, let's take a look at this backend while it's spinning up. Oh no, it says 0 added. Oh, that might be fine, actually. Let's look at this backend.tf file. We are specifying US East 1. We're creating an S3 bucket with this name. I might not have destroyed it. So it might still already exist. Let's go to AWS. Let's go to our S3 bucket. And I see we still have it up. So since it's still up, you shouldn't have to do this step in the README unless you wanted to create an entirely different S3 bucket just so you get a feel for doing this on your own. With this backend setup, we can go into our main.tf at the root level of our project Again, for the sake of this assignment, backend is something that we'll pretend already existed. Instead, our project is what we're creating. So let's go here. Let's look at main.tf. And here we could see that we are requiring that S3 bucket as a backend. We're specifying a key that we want to save our state under, and we're specifying the DynamoDB table that contains the state lock for this. And that's all this file is. This, let's see. I don't know if I need to run apply on this either. Okay, so this state is still existing. This should be good. From here, we're going to work on our module. So let's go into our module directory. And I think I have an extra folder, which you don't need. And here I have, you'll see multiple text files. These are logs that we're creating through output template. So that's another part of this exercise. At the end, once you finish setting up your modules and setting up your subdirectories and their Terraform configurations, this is also going to show you how to set up outputs and how to create logs using a template. So let's take a look at what this looks like. In our module, we're specifying a bunch of variables. These are the variables that each subdirectory main.tf file will be using. It'll be passing in values for these variables. We're also specifying the region we want to work in, and we're taking that from the region variable that we've defined. The data that's going to be used by this module, and essentially by the resources that use this module, is the DynamoDB state lock that was created through the backend. So notice, be very mindful of the variables, the keywords used to specify each block. A resource is different from a data block, which is different from a module block. That can throw you off if you're not paying attention to that. And we're also specifying what we're going to create, and that's going to be an EC2 instance with an AMI, with an instance type. And we're also going to be naming it using the environment variable passed in from the subdirectory. And then the rest of this is just output variables. This resource local file is what's going to create that output using a text template. So let's look at that template. It's fairly simple. As you can see, it's kind of like an environment file in that there is essentially a key and a value, right? But it's a text file, as you can see. And what we're doing is we are taking the values of these variables that are passed in, and we're simply printing them out to another text file. And that is what we see inside of, for example, Terraform outputs prod. These are generated by Terraform once we run our multi-apply script. Right, that's the last thing that you're going to be able to do with this exercise. You're going to learn how to write a very simple bash script that allows you to run apply on multiple subdirectories, because if we don't use this script, we would have to manually cd into each subdirectory. So cd into dev to run our Terraform init and Terraform apply. And then you'd have to cd out and cd back into your staging and prod directories to repeat that, which is no bueno. It's a lot of repetition that can be avoided using a magical bash script. And here we're specifying the environments that we've created: dev, staging, and prod. And we're then iterating through these environments. So for each environment inside of this list of environments, do the following. We're going to echo a statement so that we know where we are in our process by reading these little terminal logs. Ignore this because we're not using that. It's not doing anything. We are then changing directory into one of each of these environments, and we are running an auto or a Terraform apply with auto approve. You'll notice I have init and destroy as well. You can just quickly comment them in and out as you need to run them. So if I had already created these and I wanted to destroy them, I just go into my multi-apply to comment the ones I don't want out and comment in the one that I do want. And then I run my multi-apply script. And now we could see that it's going to run through and create these resources one by one. Let's go over to our EC2 instances. Let's take a look at what we've got. Currently nothing yet. Okay, this guy should finish up in a minute or so. Any questions on the bash script, on the outputs, on any of this? Cool. All right, let's see. We've got one environment up. So now working on the next one. For those of you that stuck around on Saturday to do the troubleshooting, I really have no idea why it was overwriting the previous environments because Phil, I know you'll remember we were talking about using for each and then using count. I did a bit.
And it just work with neither after you ran it again.
It did work, right? But then we also ran into that issue where like it was creating 9 instances and we didn't need all 9. So I did some more tweaking after we all called it a day, and I didn't even need count or for each. It's like that original issue just disappeared. It just stopped happening. So if we go into, which one is it? There's so many. That's the root one. Let's go to modules, WS, main.tf. Right. So you could see we're no longer using either for each or count here. I'm pretty sure we had this tag set to this as well, because we were able to notice that prod was being created, but not dev staging. But it stopped happening, and now we're able to create all 3. Cool. With that, I'm going to spin these down, and I'm going to let you all catch up on any Terraform assignments that you have done yet, and then to run through this one while I get up README for the Docker file, Terraform Docker file ready. So what am I doing? I'm running that multi-apply script, except I'm spinning everything down. So let me go back into multi-apply, comment this out, comment this in, save, run, and these guys should be destroyed in just a few minutes. Okay, I'm going to open up breakout rooms and I'll reconvene at 9.
I just saw in the shell script, didn't we use something different for the init when the script was ran the first time? I thought you had a different flag in the script last time.
Did I?
when we had the 9 issue and the 3.
Are you saying in here we had something
Yeah,
different?
what? Because where you have Terraform init reconfigure, I thought you had something
Oh,
else that migrated the state, maybe.
yeah. That only has to do with the state file.
Okay.
Yeah, basically,
Uh,
we had the state file locally at first. So after we ran the main .tf of the root directory, I think that gave us the backend, the S3 bucket backend with the directory that we wanted to put our remote state files in. And so because the state file already existed, it asked us if we wanted to migrate the state or to just start fresh from a new blank slate state. And that's what reconfigure is. It just lets you start fresh as opposed to migrating.
and you're saying we changed that after, so initially you had it as migrate, and then once that was ran once and we had taken care of the state file, then we switched it to reconfigure.
I honestly don't remember exactly when I switched to reconfigure. I don't know if I did that while we were troubleshooting or while I was just cleaning everything up afterwards.
Okay. Yeah, I just remember something about migrations for the init, or remember kind of having a question about it because you explained that there were 2 different ways, and what you kind of just mentioned with being able to migrate the state or make it stateless. And yeah, that was the only thing I noticed was different. So maybe I had an issue with doing the generating like 3 per.
I just don't see how though. I don't think the state should have any impact on the 3 different subdirectories using a module to create an instance.
I definitely don't know enough about Terraform to know. I'm just guessing.
It's a good guess. I mean, I don't know what exactly happened either, but we don't have a time machine. We can't go back to Saturday and see what the code looked like, unfortunately. And we weren't recording that afternoon either. I guess even if we were, the recording wouldn't have saved because I'm a boomer and I don't know how to use Zoom, apparently. All right. I'm gonna cut the recording here.